Hey everyone, thank you for joining us for the final episode of our Python web app series, Testing with Pytest and Playwright. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for Pamela to answer live. This session is recorded. It'll be available to view on demand within 24 to 48 hours, right here on the Microsoft Reactor YouTube channel. With that, I'm going to turn it over to Pamela. Thank you so much for joining us today.
All right. Hello, everyone. Welcome to the final episode in our Python web app series. So props to those of you who have been coming to multiple of these sessions. I see a few familiar faces in the chat and familiar locations that you all are streaming from. So welcome back and welcome to anyone new to the series. All the previous ones are recorded, so you can catch up on all the Python web app goodness whenever you have time. So my slides are available at this URL here, aka.ms/python-web-apps-testing. And we will put it in the chat so that you can click on it there and you can follow along and you can refer back to it later. I will just keep it up at this URL. If you haven't met me before, I'm Pamela Fox. I'm a Python cloud advocate at Microsoft, which means helping Python developers be successful with Microsoft and Azure and VS Code and GitHub and all of that stuff. Before Microsoft, I was teaching Python at UC Berkeley. I was one of the first engineers at Coursera. I was at Khan Academy for many years working on the computer programming courses and also the backend and front end. And way back when, I was at Google in developer relations working on the Maps API. So it's interesting because in the beginning of my career, I didn't write tests. I knew that was, kind of a thing. But it wasn't a big part of my process. But the longer I've been a software engineer, the more I value tests because, basically what I see is that all code has bugs, all software, is potentially buggy. It's so easy for any software engineer of any experience level to introduce bugs into code. And you just really, really want tests in order to verify that things are still working the way you expected. So now I'm a massive fan of tests, and I try to, make sure that all of my repos and projects do have tests and, aim for really high test coverage. And so I'm excited to see people here in the chat who want to learn about testing. So today we're going to start with the basics of testing. If you haven't done any testing in Python yet, we'll talk about the frameworks you can use for it and do some basic tests. We'll talk about test coverage. We'll talk about some advanced Pytest. We'll see how to write integration tests for web apps, and then how to write end-to-end tests for web apps using Playwright. And finally, see how we can integrate tests into our development workflow and like our CI/CD workflows. So, hopefully there's something for everyone here. If you're brand new to testing with Python, great. If you've done, testing with Python before, also great. Let us know in the chat, your favorite tools for that. But hopefully you, we'll all pick up something from today's session. So if you are going to be following along with the live coding, because we have, I'll do some live coding. We'll have some like kind of exercise repos that you can try stuff out in. Then I do recommend using GitHub Codespaces. For that, all you need is a GitHub account. So if you're logged into your GitHub account, great. You can use Codespaces. These are the 3 main repos that will be used for the exercises. So if you want, you can go ahead and open these repos now and click the Codespaces button and open them in Codespaces. And sometimes it's good to do that now if you are interested in following along, because it does take some time for a code space to load. So if you do it now, it'll be loaded by the time I get to it in the slides. So those URLs are here, and we'll also put them in the chat. It'll be aka.ms/pytest-exercise, aka.ms/pytest-fast API, and aka.ms/fast API-postgres-app. And there you go. Now they are also in the chat. So if you are going to follow along, those are the ones to load up now and get code spaces started for. All right, so we're going to be talking about many different kinds of tests, and we're going to be revisiting this testing pyramid multiple times. And maybe you've seen this before. So the idea of this testing pyramid is that there's different kinds of tests, and different in different quantity and quality for them. So at the bottom of the pyramid, we have unit tests, and unit tests are tests that test a single unit of our code, like the smallest units of our code. Usually that's going to be either functions or like classes and class methods, right? So what's the smallest unit that you can test? You send a function some parameters, you get back a return value. That's a unit test. So usually those are fairly easy to write, fairly straightforward to be able to, figure out what to pass in and what to get back. And so typically you can actually write quite a lot of those because you probably will have like lots of functions and classes in your code. The next level up is integration tests. And an integration test tests the way that code flows across multiple components of your program, right? It's testing that things are integrated so that if one function calls another function, that is calling it in the right way. And integration tests can be a little trickier to write because you're going over more of your code base and there's more things that can happen along the way. So typically you won't have as many of those as unit tests. At the very top are end-to-end tests, and these are mimicking the entire user flow for an application. If it's a user-facing app, it's going to mimic a whole user flow. So if it's like a web app, it would do, go to the website, log in as the user, click the profile, edit the profile, save, see that it reloaded. That is a full end-to-end test of a particular user experience. So end-to-end tests are a lot harder to write because it's complicated to go through an entire flow there. But if your end-to-end test is passing, you have so much confidence that your code actually works because you've literally tested what the user is going to do. So that's why we have these axes here, right? In terms of, unit tests, it's easy to have lots of those, but you don't have as much return on investment because they're only testing a single function. Because you could have tests for every single function in your code base, and those could all pass. But if you don't have any integration tests or end-to-end tests, it's possible that as a whole, your program just doesn't work, right? End-to-end tests, they take longer to write and also longer to run, but they give you a lot of confidence that your program does indeed work as a whole. So you want to think about this testing pyramid and think about what sort of tests you want to write for the software that you're building. I like to do a mix. I like to do unit, integration, end-to-end, right? I like to do unit tests, especially when there's some sort of tricky logic inside a function and I want to make sure that particular logic is working well. Then I really like to do unit tests. I like to do integration tests, when they're straightforward to do. And I also like to have end-to-end tests. Now, interesting thing is in the past, we've traditionally started with unit tests and then built up to end-to-end tests. But these days, some testing advocates are recommending starting at the top with end-to-end tests and then maybe finally going down to unit tests. And the reasoning is that, well, many people maybe don't even write any tests at all. Like you might be working with untested code bases today. And if you're going to write any tests, and if you have limited time to write tests, maybe you might as well write an end-to-end test because you write that one end-to-end test and you're going to get a better guarantee that things are working. So, the most important thing is to start somewhere, to write a test, write some sort of test somewhere. And then you can decide what your assortment of tests are going to look like. So we'll talk about how to write all these kinds of tests for Python web apps. We're going to start with unit tests using the Python unit test package or framework. So let me go ahead and just bring up an example repo here. So this one, you don't need to follow along for this one, or you can, just watch. So let's see. This is just to show it, not that one. We're going to do this one. Okay. All right. So this code here, let me make that real big. Okay. So this code is testing a function that is in this other file. summer.py. Let me open that to the side. Okay, so this is the function, really basic function. It takes in a list and it just sums up the values in the list, okay? And we are testing it using the unit test package. So unit test is a package that is built into Python. It is part of the standard library. So you'll find it documented on docs.python.org. And so this was the original way that most people wrote unit tests because it was built into Python. And you can see that you have to use a Python class. So we say, okay, this is our class, and this is going to be the class that's going to group together various test functions. And inside that class, we write functions or methods. And then inside each of those, we use these assert methods. So here we say self.assert equal. And I call sum scores with an empty list and say it has to be equal to 0. And in this one, I call sum scores with, an actual list and say it has to equal 24, right? So let me, look at show you the docs for this in Python. Here we go. It's in my history. So there's the documentation for it, right? And there's tons of the assert functions that you can use. There's assert equal, assert true, assert false, assert greater than, assert raises, all the sorts of things you might want to assert about the return value of your function. So this is good. It works. We'll run the test and make sure that that things are passing. So to run this, we're going to do python-m unit test. So we're telling Python to use the unit test module in order to test this file. So we're passing the unit test module this file. So let me try that. Let me actually go into this folder that I'm using. All right, and we can see it says that it ran 2 tests. And let me just try passing in verbose. And there we get a little more of a verbose output that says, okay, we ran this function and it was good, and we ran that function, it was good. If we had some sort of bug in our code, like an off by 1 error, then we would see a failure on each of the tests, actually, that said, what was the difference in the expected and the result. So that's running a particular test. We can also do python-m unit test and not specify a file. And if we do that, we see the same results. And the reason this worked is because unit test has what's called like a test discovery algorithm, which means it has a certain way that it'll try and look for things that look like tests. And its particular algorithm is documented in their documentation. But basically all testing frameworks will have some sort of test discovery algorithm so that you can just run the testing framework and it will find your tests. So in this case, the reason it found it is because I did name the file test underscore, and it was able to find the file because of that. So that's unit test. The thing about unit test is that it was programmed based off of Java's unit testing module known as JUnit. And because of that, it's actually very Java-like. It's not as Pythonic as we might expect for a Python module. So, it's cool. It works. I've definitely, written it in lots of code bases. But what I really like and what we're going to focus on for the whole rest of the time is Pytest, which is actually a third-party plugin. So that was unit test. I wanted to let you know that it exists. It's cool. You can use it. There's good docs for it. But these days, I'm really embracing Pytest. It's very, very popular with the Python community. It has a huge ecosystem, huge amount of support, and it's just really, really, really nice to use. So that's what we're going to use for the rest of the session. We're going to start off with using Pytest for unit tests, but as we'll see, we can use Pytest for every level of the pyramid. And that's another thing that's very cool about Pytest is that it's really flexible and can work for all kinds of tests. So let's look at the same test with Pytest. So I've got a different file here. Okay. So with Pytest, we're importing our function that we're going to test, and then we just write a Python function. That's it. It's a Python function that starts with test underscore. So that's what indicates that it is a test function. And then we say, okay. And now for how we assert, we use the Python assert statement. So assert statement is actually a statement that's already part of Python. So Pytest was like, well, what can we use that's already in Python? So they just went ahead and used the assert statement. So you just write assert and then some statement after that that has to be true, right? And if it's not true, it will fail the test. So we say, okay, assert that the sum scores equals 0. So you can put anything here that is, truthy or falsy, and that would be your test assertion. So now let's try running this test. So I'm going to say, well, first I'd have to install Pytest. I'm sure I've already got it in here, but I'll do pip install Pytest anyway to show you that we have it installed. And then the next thing is to do python-m pytest, and we're telling it to use the Pytest package, and I'm going to give it the name of the function. So it's sum scores test.py, and we can see 100% it all passed. Now let's do verbose, or actually you can do -v, or you can do 2 V's, or you can do 3 V's. The more V's you write, the more verbose your output will be. So I'll just do VVV. And in this case, it's actually just as verbose because it's just passed. But there we can see exactly which of the functions passed, and it kind of shows you the progress along the way. We can also use the Pytest test discovery algorithm. Now, this is actually going to be kind of interesting. So it discovered 2 files. Let me VV it. It discovered that original file, the one, this one here, test sum scores, the one that had the unit test case, and it ran that file. So this is what's really cool about Pytest, is that it understands Pytest tests, but it also understands unit tests. So you could actually mix and match. Like if you're in currently a unit test code base and you're like, ooh, Pytest looks cool, you could start using Pytest now and still run your old unit tests, because Pytest knows how to run both. And it basically, its test discovery algorithm is it looks for things that either start with test underscore or end with underscore test. So it was able to find both of these. All right, so we ran those tests. Now we can configure Pytest, and we can configure it by passing in different options. We can also configure in our pyproject.toml, which is a way of setting up a project. So if you haven't used pyproject.toml before, it's something that you can put in your Python project that you can now use to configure lots of tools. And it's actually a Python standard now. And, I use it for all my projects. Like if you want a nice project just to get started, I have the Python-project-template. This is my starter project that I use whenever I'm starting anything new Python thing. And I already have a pyproject.toml in here to configure the most common tools that I use. So it'll configure rough and black and Pytest and, coverage, which we'll talk about soon. So I like to configure in pyproject.toml, but you can also just pass things into the command line when you're running it, right? So you can say -RA, and I think I already have it configured here. Yeah. And you can check the Pytest documentation to see what additional options there are. I actually don't even remember what RA is. I just know that I always use it. So presumably it's pretty cool. Okay, so now let's do an exercise. So this is using aka.ms/pytest-exercise. So if you want to follow along, go ahead and open this code base now. So I'm going to go here, and I've got a code space running already. So I'll go ahead, open this up. Right. Okay. So now this is a code base that has, let me make it bigger. All right. We've got this texter.py, and it basically has a bunch of really fun functions, right? So let me actually just run this first. So I'll do python-i texter.py. So that'll run texter.py, and then, let me get the right directory. Source/texter.py. So that runs texter.py and then puts us in a repo where we can call any of the functions from it, right? So if we do like the leet function, you might be able to guess, that's going to replace all the E's with 3's. Okay, not very fancy, but like clapify, like Pytest is the best. There we go. And that returns back, something that we can just go ahead and Go and like toot it, right? Here we go. Tooted. Let's see. Emojify. So Emojify, and let's see. I love Pytest, best in the world. And here we can see, oh, I heart. Let's actually add love to this one. Let's see. Love, love, love. Love. There we go. All right. That way we'll get love next time. So this goes and replaces various words with emojis. That's fun. And let's see, shortener. Let's try the same thing with shortener. Shortener. Got rid of all the vowels, and then exclamify. We'll try that. Adds exclamation points. So we have all these text manipulation functions, and these are the kind of functions that, we'd want to test with a unit test to make sure that they are, working as expected. So here we've got a file with the text, and generally you're going to put your tests in a different file so that you can have your tests separate from your code. And that's nice because your tests can get really long and really not that nice to look at, depending on how much you got going on in them. So it's always nice to separate them from your main file. So I'll just go through and write some tests, or let Copilot write my test. I have to say, like, Copilot is generally pretty good at writing tests. Like in this case, let's see, give it an emoji. Hello world. And here's the thing is, you can always write a test that's wrong, and then you'll find out what's wrong about it, and then you can fix it. Shortener, and this one's going to be world. And okay, so let's just run those tests first to make sure they're working. So I'll do python-m pytest. Okay, that's all working. Then we can do the VV or V, and we can see them, they've all passed. Now, Exclamify is an interesting one, because if we look at Exclamify and we look at the code for it, it is actually using, it's using random. Where's random? No, Exclamify is here. So Exclamify has this list of exclamation marks, and it randomly chooses from these exclamation marks. Now, when you are testing a function that uses random, that's tricky because it's going to be randomly different each time, right? So let's just try this without doing anything special. So we'll try this, and we see, oh, it was wrong. And then I might be like, okay, well, let me fix it. And then I say, wait, this time it's wrong again, right? Now I could keep trying to fix it, but every time it's going to be different, right? Because it's literally randomizing it. So what we can do is say random.seed. So what this does is it sets the seed. And this isn't something we want to do in production because we actually want random. But if we do random.seed, then we can actually guarantee that what gets pulled out of the random list is going to be the same each time. So let's see what it is when I do seed. It says that it's actually this value here. So I'm going to go ahead and change that. And now each time I run it, it's the same each time. So if you are testing something that uses randomization in your tests, you will need to set a seed so that you can ensure that you have predictable output. Otherwise, you're going to have failing tests, every so often or very often. Okay, so great. So that is that, we've written tests for those functions, and they're all passing now. And good to go. And I don't see any questions about, I do see a question. We will definitely talk about that one later. I think that the answer is yes. So now let's talk about coverage. So when you're writing tests, right here, we can look at it and say, it looks like, I've tested all the functions. That must mean that I'm good to go. I've covered all my bases, right? I've written all the tests I could possibly write. What you want to do is actually to use a coverage tool. So a coverage tool will measure the percentage of code that is covered by your tests. So that if you're not sure if you've actually covered everything, the coverage tool will let you know, like, hey, this line of code got covered or this line of code didn't get covered. Now, you should start off with line coverage, which is just whether a particular line of code was executed. But if you want to get more sophisticated and really have more confidence in your tests, then you can use branch coverage, which is whether a particular code path was followed. And this is the most relevant if you have complicated conditionals that have multiple Boolean conditions that could make it true. Because you could have a test that actually does end up hitting every line of code, but maybe doesn't hit, maybe there's different orders you could hit it in, and there's like a horrible bug in one of those, orders that you could hit up those conditions. So for a lot of confidence, you would ideally do branch coverage. Now, the most popular tool in Python is coverage.py, and you can use that to check for when you're using Pytest or unit tests. It can watch to see what lines of code have been run. And then it can give us a report that says, okay, here's how many files were in here. This is what was covered, and this is what was missing. So let me try that out in my basic repo from before. So I'm going to pip install coverage. And then I am going to run coverage when running the unit test. So I'll start with that. So I say coverage run, and then I do my unit test command. Okay. So it runs the tests. And then what I can do is coverage report. And I can get back a report that says what actually got covered. So it says, okay, 100% coverage of summer.py. And then I can do the same thing with Pytest. All right. And then I can do coverage report. And now that one is interesting because it's actually showing the Pytest package too, presumably because Pytest got executed during it and coverage wasn't sure what we cared about. So what you can do in this case is pass in a parameter to coverage to say that you want it just to check the coverage of this particular folder. So I'm going to say source equals dot, which says we only care about this current folder. We don't care about the Pytest package itself. So let's see if that works better. There we go. So now we can see that we've got 100% coverage of summer.py, which is the one we care about. There's some things here that we haven't written code for at all, right? So that's one way of doing the import. There's also coverage HTML, which is an HTML report, which is super cool. And this is really the nicest way of checking to see what your coverage looks like. Let me open it up over in this one over here. All right. So what this will show you is, we've got this overall table, but then we can dig in and say, okay, well, can you show me, exactly what lines of code here? Now, in this case, I covered all the lines of code, so it's not very exciting. But if there were any missing, I could actually see what was missing. I think I actually ran it the other day for a much more complicated repo. Let me see if I still got that open. Coverage HTML. Okay, let me see if I can open up this one. Yeah, it's so cool. I get such a kick out of coverage. So this is what it would look like for, a really large repo, right? And this is more realistic because in most repos, you're not going to get to 100% coverage just because limited time and resources and all that stuff. So what I can do, is look at it and say like, okay, well, app.py, which are the things I'm missing here? And is it important to me to test them out? Like I probably should actually test out this one here because that's an entire route that's not covered. Versus like this one here, that's just an error response. Not quite as big of a deal that it's not tested. A lot of my things that aren't tested are error responses and exceptions. So that to me is not as big of a deal because those are exceptional cases anyway, but you can add tests for absolutely everything. These, some of these I should probably test. So it's super, super useful. And, what you can do is that you can have like kind of like testing parties where you go and try to increase the coverage of your application, and you just run the coverage, you look at the report and say, all right, this is where we need more coverage is, on these lines of code here. Yeah, I see a comment about 100% test coverage is the dream. Yeah, that is the dream. It really helps if you start off it with tests. Like if you start off with tests, then it's much easier to get to it. This was a repo that started off with 0 tests at all and wasn't even testable. The way it was architected was not really testable. We had to first re-architect the repo for testability, and then we could add the test. So I always recommend start off with at least 1 test, because if you start off with 1 test, then you know at least that you've got a well enough architected code so that it can be tested, so that you can add more tests, right? You know, the first test is the hardest. So just start off with that 1 test, and then what you can do is, you know, keep adding, and you can have thresholds that say like, oh, you can't add more code unless you stay up, you know, with this threshold. So I do have like testing coverage requirements for my repos. I think I do have one that's an actual live repo that has, I think it has 100% coverage. Let me look what's in my workflow for the tests. Coverage. No, that one doesn't. But I can look for fail under. No, it's not fail under. Oh yeah, wait, let me just look across my whole GitHub. Nope, that's not me. Oh, I don't know who that is. Okay. Let's look for fail under. There we go. Okay, so I do have one. So you can set this fail under for coverage. It says like, okay, if your coverage is less than certain percentage, then you're just going to fail under. So I do have some which have close to 100%. This one's 98. This was one I was working on recently. So what you can do is, you know, start off with 1 test, keep trying to work up to 100%, and at least don't let your coverage amounts slip, right? You should ideally be increasing those, you know, that coverage threshold and not going lower. All right, so we viewed that report. Now, there is a Pytest Cov plugin that makes it super easy to run coverage with Pytest. So that's typically what I'm actually using, because then when I'm running Pytest, I just say --cov, and then I just pass in all my options that way. So with all of my projects, I'm always using the Pytest Cov plugin and configuring that plugin. All right, so going back to this repo before, what we're going to do is add in some of my favorite options for Pytest Cov. So you can see that this is already including Pytest Cov in the developer requirements. So we've already got that package installed. So what we can do is here, when we add options to Pytest in the pyproject.toml, we can add all these coverage options and say, okay, we want to check the coverage of the source folder. We want a report, and in that report, you should say what lines are missing. So those are my, you know, kind of standard things that additional arguments I like to use. So now if I run Pytest, we can see that after it runs the test, we then also get the report. And in this case, it's 100% and there's nothing missing. But what we're going to do is move this conditionals.py into this file here, and then run that Pytest again. And now it sees there's this new file, and it says every single line of code is missing. Okay, so that's not good. So, you know, what we're going to do is add a new file here, and we'll say from source import conditionals, and then we're just going to we should probably check to see what we're testing. Okay, test greater num, and that should be assert conditional that greater num. That looks good. Okay, all right. So I wrote a test, and now when I run it, you can see I now have 30% coverage, and it says that I'm missing lines 14 to 18, and also missing lines 25 to 34. So I'm basically missing the function bodies for these 2 functions here. So I could keep going and, you know, add in those as well and keep working up to get 100% coverage. All right, so that was coverage. I saw some questions in the chat about Pytest fixtures and patching. So let's go ahead and talk about that. So a lot of times when you are writing tests, you may have a situation where your code uses some sort of functionality that's hard to actually replicate in a test environment. And if that's your situation, then you can monkey patch that functionality. That's how we generally do it in Pytest, is with a monkey patch fixture. So let's go ahead and look at an example here, right? So imagine this function here that takes in input from a user. So if we actually like ran this function here, let me go run it over here. Okay, input number. Yeah, input a number. And this actually, wants input from me, the user. This function is paused and is not going to continue until it gets input from me. And so then it gets that input, it turns it into an integer, and it returns it. So this looks like a really simple function, but this input function here, that is a built-in function for Python that gets input from a user, and it's just not going to work inside a test because it's going to sit there and it's going to wait for a user to enter something. But in a test situation, a user's not going to enter something, right? So this is the sort of thing that we would have to mock out in a test. And luckily we can. So let's go ahead and see how we can do that. Okay, so let me simplify how we could do it here. Let me just test this. Yeah, test input imp. Okay, so what we're going to use is this this feature called, I'm going to move these off screen. All right, so it's a feature called the monkey patch fixture. All right, so first we have to talk about fixtures. What are fixtures? In Pytest, fixtures are this way of bringing in functionality into a test function. And you identify fixtures by putting the name of the fixture as the parameter name. So what happens is that Pytest looks at this and says, oh, monkey patch, do I know about a fixture named monkey patch? Yes, I do. I'm going to bring it in. So it's like importing into a function. And this is probably maybe the weirdest part of using Pytest, is just the way this works. It can be a little complicated, but we are using a built-in fixture for Pytest. So if you look at the Pytest docs, you will find all the docs about monkey patch because it is built in. So we can bring it into any Pytest function. We can bring it in. So we bring that in. And then we do what it says here. So what we do first is we're going to make a fake input function, which will be a string that returns a string. So we are faking out how that built-in function works, right? We're saying like, okay, well, when you get a string, you're going to return a string. And then what we do is we're overriding the built-in. So the way we override a built-in is we actually say, okay, we're changing built-ins.input, because this is actually how Python thinks of it. So you have to figure out how something is actually brought into your code. And for built-ins, it's built-ins the name. And so this is like, if you're going to mock out any of the built-ins, I don't know which other built-ins you'd want to mock out, but these are all the built-in functions. These are the ones that you can refer to in any of your code. And these are actually all from this built-ins module. We don't usually refer to the built-ins module, but they are actually from this built-ins module. So we are mocking out this one here. So we're just making a function that has a similar return value and input value to the built-in. So we say, all right, we're going to mock out built-ins.input, and we're going to replace it with this fake function here. So that's what it's going to do. Just for the duration of this test, it will fake out that function with this one instead. So then I should be able to say, assert input number, enter num equals 5, right? So I'm now testing this function here. And when this function gets called, it's going to actually end up calling this function here. And then it'll turn that into an int and then return it, right? So this is how I would monkey patch that input function. Let me actually put that like in a, let's see, like could put that in a standalone file. I wonder if it'll let me actually run this as a Pytest file, even though I did not name it with a testing thing, but we can try. So input func.py. Okay, yeah. So the first one actually, let me do -v. Just input int. Oh yeah, and then I did that. Okay. All right, so this one has passed. Okay. So we've got that set up. Now, let's say that we wanted to use this mocked input across multiple functions. What we can do then is we can turn it into a fixture. So what I'm going to do is take all of this here and put it inside this function here. So this function is not a test function anymore. This is a fixture. And I've marked it as a fixture with this decorator here. So I say @pytest.fixture. So this tells Pytest, hey, I'm making this new fixture. This new fixture is called mocked_input. And so any test going forward can refer to this fixture. So that, and a fixture can bring in another fixture. So this brings in monkey patch. It does this. So now any test that I have that needs this mock, I can just bring in that fixture. So I say, okay, well, this test here, it needs the mock input fixture. And, and then I'm going to run these tests here. I guess my linter doesn't like my test. Fine. I'll fix my test to make my linter happier, right? Okay. And there we go. Okay. All right. So now all of these pass. So to go back, there's an early question, like, tips with using fixtures and mocks and stuff. What I very often will do is that I'll make a mock that uses monkey patch, and I set it up as a fixture to make it easy for me to use that, to bring that mock into multiple functions. Now with fixtures, they do have a scope, and there's a default scope for them. And the scope is useful because it determines how often it's going to be rerun. So if a particular fixture, you just need to run it once, and then that same fixture will be fine for the rest of it, then you can, set that to like session. But if you need to like rerun a fixture every time, like imagine your fixture is like completely clearing out some variables or something like that, and you need to make sure that every single test is going to be fresh, then you might want to change the scope to function. So do think carefully about the scope and whether it's fine if it runs the fixture just once for the whole session and then kind of reuses that, or if it needs to be run repeatedly. A very common kind of fixture would be, something with like seeding data or clearing data when you're doing a database. So, here I just wrote some like pretend code here, but you can imagine having a fixture that had seeded database data and, it would insert data. Maybe it would also like clear out the data, right? So this sort of fixture would be really common for a web app. So yeah, those are some monkey patches, some fixtures. I use monkey patch and fixtures all the time. Like if we go and look at that, really the big code base, and if you look at the, my code, I can see that I referenced the monkey patch fixture 117 times in this file here. Now this file is conftest.py. So if you make a conftest.py file, that file will always be read by Pytest before anything else. So that is where you're going to put your fixtures, is in conftest.py. Any fixtures that you want to be able to use across all of your test files, you put in conftest.py. So this is just all of our, important fixtures, right? So here you can see example, this is a fixture to mock out an API call to the Azure Computer Vision SDK. If you are dealing with APIs, you're going to be doing some sort of mocking. There's many different kinds of mocking you can do with APIs. In this case, I was like mocking out a post using the particular HTTP package that we're using and saying like, okay, if you get a post to this URL, then you're going to return back this JSON response or whatever. So many ways to patch APIs. Like sometimes I do it more high level, sometimes I do it more low level. But these are almost all of these are actually patches of API calls. This is if you want to mock out as your OpenAI. If you need that for your test, you should just steal it from our comp test, because I have mocked out everything. So a lot of testing is actually writing mocks, and it's actually probably the hardest part of writing tests in my experience. Oh, I saw a good question was, are there cool VS Code plugins to show you which lines are missing? I love that question. I feel like I even tweeted that the other day, and I don't remember the response, or tweeted it. I would just check for coverage and see display test coverage generated by LCov, or yeah, this would probably work. So coverage tools have we could try it and see if it's just going to work. Coverage tools generally conform to these standard formats, so LCov or XML. So that's what's nice about them, is that if they all conform to these standard ones, so even across Java or Python or JavaScript, whatever, as long as they conform to that. And so you can see examples here. Oh, I think I've even used this before. Now it's all coming back. It's all coming back to me now. So definitely check out this one. I'm pretty sure this is the one I've looked at before. Don't know if it's just going to like instantly work, or if we had to set it up, because here's my coverage folder. I think what you have to do is explicitly tell, if we go back to the extension and look at the Python example, I think you may have to tell coverage to, oops, that's not the Python link. All right, let's see. So this is their Python example. Okay, there you go. So we say -cov report xml cov.xml. Okay, so that's the additional line that we need when we're running the Pytest. So let's see if I run that, if it's going to run cov report. I think I have cov Pytest cov report. Do we need a new one there? I should just set this up for all of ours, because it's a really cool one when it works. XML. Let's see. -cov. Oh, okay. So this one, I didn't install Pytest cov. All right. So we're going to install Pytest cov in this environment here. Okay. And let's see if that's going to work this time. Okay. So then that made presumably like a cov.xml. And then we go here. Is it going to know where to find it? No, I don't see the gutters. I don't see the gutters yet, but I think it could be just the location of it. Where's the cov.xml? Cov.xml. Cov report. Okay, well, it's not instantly working. I'm guessing it has to do just with where things got put or something. But I think that's a great point, and I think I should probably just change my Python project template to just have this extension and have it set up to be able to use it really easily, because I think that would be a really, really nice experience. All right. Great questions. So let's see. We talked about monkey patch. We talked about fixtures. And generally, for more Pytest, we're not going to be able to cover everything in Pytest today, but there's great Pytest documentation. Brian Ocken has written a great book. That's what I first read that got me hooked on Pytest. So I do recommend his book. He also has an online course version of it now that you can go through if you prefer online courses versus books. He's also got a podcast about testing. So Brian is really into Pytest, and he's great. There's also another book on test-driven development with Python that covers a lot of Pytests. So definitely recommend digging into Pytest to learn all the things you can do, because it's really, really powerful, and there's some very cool plugins, and you can write your own plugins. I think at this point I've written, I don't know, 5 Pytest plugins maybe. or maybe I'm being optimistic, but it's a great way to contribute back to the Pytest ecosystem. If you've done some sort of functionality that you think might be generally useful, you just wrap it in a plugin and you just put it out there on pip, and other people can use it as well. All right, so now finally let's talk about testing web apps. I know I said this session is about testing web apps, but wanted to make sure we had a good solid foundation in testing. So let's test some web apps. So in this series, we've talked about the most popular Python web frameworks, so Flask and Quart, Fast API, and Django. All of them provide a testing client class to make it easier for you to make tests, in your Pytest or unit test. So you just have to know, and look at the documentation to figure out how do you make a test client for that particular framework, right? So an example here is from Flask. It has this test client, and so if you have your app object, you create a test client based off that. Now you can send requests to that client. So because what we're trying to get is something that we can send requests to and get responses back, because that's the way that we're going to start off with testing our web apps, is sending a request, getting back a response, and confirming that we got the response we expected. So there's an example of Flask. We're actually going to work through a Fast API example, but they're all actually pretty similar. So for this one, we're going to go ahead and open this other code space. Let me close all these things and open up this one. So this is just going to be a really, really simple Fast API app. We can look at the code here. So we create this Fast API app. We add a single API route for it. And that API route takes in a optional parameter, starts with, and it iterates through a list of names, and it returns back a random name, and it spits back JSON. That is our API here. So there's the code again. We can go ahead and run the local server so we can see the docs. Let me make this bigger. Okay. And we're going to open and go to the auto-generated documentation. And here we can just try out our API, and we see the request and the response. So this is what we want to test in our integration test, is if we hit up this route, generate name, and we pass it the parameter of n, do we get back a JSON response that looks like this? So let's go to our tests. And what you can see here is that we are using the Fast API test client. We're importing the Fast API app object from main.py. So that's this object here. So we're importing that into the test. We're creating a test client. And then we're using that in each of them. Now, there's another way. Let's go ahead and show another way of doing making that client that's maybe even more common. It would be app client. So I'm going to make a fixture. That's what I'm going to do. So at pytest.fixture app client, and it's just going to return a test client from app. And so then I go through here and refer to that fixture, and then it brings it in. So this is actually normally the way I do it. It's effectively really similar to having the globally created client, but it does give me more control, because now I could change the scope of it. If there were if I needed to have kind of set up and tear down things between tests, I could change the scope to be like a function scope or something. So this just gives me a little more flexibility by wrapping it in a fixture and bringing it in that way instead. And then I might also just even have this in a comptest.py if I'm going to have multiple test files. In this case, I only have a single test file, so I've got it all in this one file here. All right, and then this is a random name generator, so we do need to use that technique of setting the seed. So we say random.seed1. we tell it to send a GET request to this route here. We confirm that the status code is 200, and then confirm that the JSON that comes back has a name field set to Belton. And then we do the same thing, testing and parameters, testing uppercase, anything that we think might behave slightly differently. So I think like 100% coverage is just the beginning. You might have 100% coverage, but there still could be many things that you haven't actually tested yet. So 100% coverage is just the beginning. All right, so let's go ahead and run these tests. Python-m Pytest. And I realized actually I haven't shown you how to run tests with the VS Code testing tab, so we should definitely show that as well. So if we go over the testing tab, the testing tab actually can auto detect tests that you have. So the testing tab also has its own discovery mechanism. Sometimes you do have to set things up. So I think in this environment, I have some settings. So I tell it, so these are VS Code settings. So I've said that I'm using Pytest, not unit tests. So it'll know to look for Pytest tests and run it that way. I've said, and the rest of these are all linting stuff. So yeah, the only thing I've done is actually told it that I'm using Pytest. So this might be a setting that you want to have in your project to help the testing tab out. All right, so it found all the tests. So we can go ahead and, we can run just a single test if you want, and that'll run a single test. We can run a whole file of tests. We can run everything in a folder. We can, you can do it at any level of granularity. And what's my absolute favorite though, I don't know if this is going to work. I can't remember if I've set this up correctly here, but in theory, this run and debug means that you can actually debug your tests. So actually I would need to put a breakpoint. Let me put a breakpoint in. Let's try that again with a breakpoint. Because sometimes your tests don't work and you're not sure, did you not mock something correctly? Like what's actually going on, right? So you can see here that it's actually brought me into the VS Code debugger, and it has stopped at the line where I put the breakpoint, right? And we can see the app client, and then we can go and see what the response looked like. And this is also, I also use this when I'm just trying to figure out what can I assert, right? I might be like, oh, I also want to assert the, the encoding or something, right? Depends just what I'm testing. So it's also just useful to go into this debugger mode just so you can see, what you're dealing with and what sort of properties you might want to assert. And I think we should be able to set a breakpoint in our app code itself too while we're running the test. So let's try that out again. Okay, so then I'm going to go past this one, and good. Now it brought me into the app code. So if you think there's an issue with your application code that's causing your test to fail, you can jump into your app code as well and then go through and say like, okay, it didn't go into there because I didn't have a starts with, and then it did this, and then it returned. So it's really nice if you can use this testing tab, especially if you can use it with run and debug, because it's super powerful to be able to actually just dive into your tests and debug them that way. It's actually pretty painful to use print debugging for tests. You can, if you do need, I'll show you the tips if you have to use print debugging for tests. All right. So imagine you have a test and it's being, annoying. Like what you don't want to have to do is to run Pytest on every single test every time. So like, let's put a, let me actually put a bug in here. So I'm going to get rid of the dot lower. Okay. I think that'll be buggy. And we'll do it with the upper. Okay. So, let's say I went and I put like, if I was doing print debugging, like, okay, name choices and print starts with, okay. All right. So let's say I run Pytest with just this. Okay. Python-m Pytest. And what you can see is that we do see all that output. And we also did get an error as well, right? So one thing you want to do is only run a single test. The easiest way to do that is just do -k. -k is a keyword search of your tests where you can say, okay, just only run the tests that match this search query. So I can just put in straight up just the name of that test. and then it's only going to run that test. So that can be useful if you're debugging just a single test. Like you shouldn't have to run every single test, just run that single test. Or if you're trying to only debug a single file, just pass the name of the file. It's very powerful way of just filtering stuff down and pretty fast. But much nicer to do actual VS Code debugging if you can get that all set up correctly. All right. Cool. Okay. So we ran some tests and and we could go and you could add another route. So just say like add a route for pet names as well. Okay. And we'll just let Copilot. You never know if it's who's going to be faster. You or me, kid. Okay. And we'll just copy and paste this, except in this case, it's going to be, there we go, some pet names. Okay. So now we have a pet name route. And then we need to test the generate pet name route. Yeah. And there we go. Okay. So now we're going to go and see how our tests are doing. See how our coverage is. And apparently the randomly generated name was Rex. So we will change that. And we still have a test on the old one because I didn't bring back all of the original fixes. Okay. And here we go. We can say, we can see that required test coverage was not reached. So I'm missing line 18. Right. So this is what you can do is this, so here I've got this threshold of 100% that I need to reach. And so I need to go ahead and hit up that one as well in order to get to that 100% coverage. Right. So we'll go pet name starts with R. And then let's see what we get back. Okay. And now we're at 100% coverage. And so we can feel pretty good about our API. There still could be bugs because, just because we've hit up every branch and every line of code, there still might be things that people can pass in that we don't handle well, right? So there could be something like, what if I pass in, I don't know, is this going to work? Let's see. Definitely not going to be Rex, I'll tell you that much. But no, this one actually results in an error, right? So this is the interesting thing is that you can have 100% test coverage, but still users can pass in input that you didn't expect. So what you can do in this case is that if you really want to guard yourself for any kinds of user input, especially if you're building an API, right? Because you never know what people are going to pass in APIs. So what I usually recommend in that case is to use schema thesis, which will do property-based testing on your API. So it'll actually send a bunch of potential values to your API based off of what inputs you take. So, it'll send uppercase and lowercase and long strings and short strings, all of that, empty strings, and see if it gets, 200s back from your API. So I actually do have that set up. Like for this charts API app that I have, it's an API that uses Matplotlib to build charts. And I use schema thesis in order to send lots of requests at it and find out if there's any issues. And this is actually really useful. It's actually caught issues with Matplotlib updates, which I wasn't handling. So that's what I recommend if you really want to have a lot of confidence, especially if you're building something like an API where you can get arbitrary user input, is to do property-based testing using something like schema thesis or hypothesis, which is what it's based off of. Okay. So I see a question about where can I find the slides in the GitHub repo. So this is an HTML web page. This is not a PDF. If you do want it to be a PDF, then you can just put, let me remember how you do it. You do PDF, print PDF. Okay. So if you do want a PDF, you just do question mark print PDF at the end, and then that will put it in a nice view where you can just save as a PDF. And wherever you're like, oh, so like print as a PDF, and then that would print out a nice PDF. Yeah, so that looks like a nice PDF. So you just save that as a PDF. So that is how you can do it, since these are HTML-based slides instead of like PowerPoint or PDF. Cool. All right. Yeah, sorry I don't have that auto. Sometimes I set up my slides to auto-generate the PDF, but I don't have these ones set up for that. Okay, so finally, we're going to talk about end-to-end testing using Playwright. And I think some of you maybe are specifically here for Playwright, so hopefully you've stuck around for this part of it. And we're once again going to use Pytest, but we need to do end-to-end testing, and we're doing this of a web app, which means we actually need to do browser-based testing. And so this is where things can get really interesting. So in the past, what I've always used for browser-based testing is Selenium. And there was a comment from way earlier about whether Playwright is like the younger, hipper version of Selenium or something. But I think that's actually true. So Selenium, I mean, I use Selenium at Google and Coursera and Khan Academy, and we used it for all of our end-to-end tests. And the good thing about Selenium is that it can be used for a huge variety of browsers, and it's very, very faithful because it's actually really testing it in the browser that the user is going to use. But we tended to, when we wrote tests with the Selenium style of writing tests, they tended to be fairly flaky. Playwright is this newer offering. It's from Microsoft. So obviously I'm biased. I'm from Microsoft now too. It's from Microsoft. It is a more limited browser wise. You can do Chromium or WebKit, but it doesn't have quite as many browser offerings as Selenium. But it's way faster and generally less flaky because of the way they encourage you to write tests. So Selenium encouraged you to write tests using like exact CSS selectors, which would tend to change a lot over time. Playwright encourages you to write tests based off of what the user sees, which tends to actually be more stable. So we'll see this when we actually look at the tests, but that results in Playwright tests being flakier overall. So let's get started with Playwright using our final repo. So I'll go ahead and open up this one. Oh, I see a question about Cypress. I have not used Cypress myself. I know it is another framework, and I probably should have put it on the slide, but I don't know if it's using. Yeah, I haven't used it myself. So if anybody has used Cypress, please post a comment so we can learn from you. I wish I had time to learn everything. That'd be so cool in my fantasy world, my quantum universe. Okay, so here I've got this this repo open. So it's aka.ms/fastapi-postgres-app. And maybe we can put that one in the chat again. So the first step is to install quite a few things, actually. We need to install Playwright, the Python package. We want to also install Pytest-Playwright, which is the Pytest plugin for Playwright, or the Playwright plugin for Pytest. And then we need to install whatever browser we want to run the tests in. So by default, it'll actually install like Chromium and WebKit, but we're going to install less by just installing Chromium. So I'm going to run all this install, and hopefully I already did it. If you're doing it now, I will warn you, it does take time to install. It takes like 5 minutes or so maybe to install Chromium and the dependencies for Chromium, because you're installing a whole browser and there's a lot going on there. Luckily, I did it earlier today, so we're all set, and I've got it in the environment here. The next thing is to have a test that we can run. So I've already got some tests here. So I can go ahead and open up test_playwright.py. And you can see the tests here. So we bring in Playwright. This is a really basic test home. And it brings in a fixture from the Pytest Playwright Pytest Playwright plugin. So that's actually from the Pytest Playwright. This is a fixture that we wrote ourselves that I'll explain soon, but it basically starts up a live server for us, like in the local environment. And so then we tell Playwright that it's going to go to the URL for that local server, and then it needs to check to see that that page has a particular title. This is our most basic test, is basically, does the page load? Which is like a pretty good start to make sure your page loads. So let's talk about that live server fixture, because this is actually a little bit tricky. So in order to be able to run tests against a local server, we need to be running a local server, right? Now, normally we run a local server using like, the Fast API development server or using Unicorn or something like that. So we need to do that automatically for our tests. So if we go to the conftest.py, you can see basically what we do is we are using multiprocessing in order to start Unicorn. So this is Unicorn. We're using Unicorn to run it. So we're telling Unicorn to run the app on a particular port. Now the port part is tricky too, because you're trying to get a port that's not in use. So you don't want to hard code a port, because then very likely you're going to run into issues, especially if the tests get like run in parallel. You want to pick a port that's not in use by the rest of the system. So I actually use a package for that called Ephemeral Port Reserve, and it will pick a port for me. So we run the app at that port. We check to see if the server is ready, because it does take Unicorn time to start up. So we have this wait for server ready function that repeatedly pings a URL to see until it finally, doesn't get a connection error. And then it says, okay, it's ready. And finally it yields that URL. So this is something interesting we can do with fixtures, is that we can return things from them using yield. And then we can do stuff after a test is done, or after the fixture is done being used. So this will yield the URL. And then at the end of the session, because this is scope to session, it will kill that process and also drop all the data from the seed database, the test database. So a lot going on there. What I would encourage you to do is that if you are writing apps for tests for Fast API or Flask or Django, we've already figured out how to do a live server. We have examples for all of those. Just take our live server because we spent a lot of time figuring this out and making sure it worked. And there's a lot of complexity to it, especially like getting it working across Windows and Mac and Linux and all that stuff. So please just take our conftest.py, take the live server fixture, and just use it for your code, so that you don't have to deal with that yourself. Okay, so that brings in the URL that we got from this function here, right? So so that's what we get from that fixture, and then we can go to it. Okay. So the next question is like, how do you even like write tests for this, right? So this was like a really, really basic one, but most of the time your tests are going to be actually like clicking around. So what I want to show you is the code gen tool. So I'm going to go ahead and actually run this locally. Okay. So let's see. I think I've got it running. What's the port? Okay. 8,000. Okay. So I've got this running locally. So it's running on localhost 8,000. And then what I'm going to do, and I'm going to go, and I'm doing this all locally because I will admit some of this stuff is hard to do in code spaces, because you're going to see what happens. It's actually going to pull up a Chromium in a whole new like application window. So you just can't, unfortunately, you just can't really do it in code spaces right now. So there, we can run the test in code spaces, but for this part, I do have to do it locally. So what I'm going to do is run Playwright code gen, and I give it the path that we're going to be testing. And so what this does is that it's actually going to bring up Chromium, and it's going to bring up this code gen tool from Playwright. So it's all starting up right now. So here you can see it's this tool that, it kind of shows me as I'm mousing over stuff. And then it has this code over here. Can I make this bigger, 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 bigger? Okay. So this is the code that it's generating as I'm clicking around. So let's say I want to test this destinations thing. So I go to destinations and then I go here, and you can see as I'm clicking, it's filling out this code here. So this is actually how they encourage you to write tests, because what Playwright is going to do, it's trying to figure out the simplest locator it can use that's still unique on a page. So instead of like, if you know Selenium, in Selenium, we would just like hard code CSS selectors and be like, find the div that has the link and blah, 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 right? But Playwright tries to figure out what is like the user, what's like kind of a user facing label. So it says, okay, find the destinations link. So if there's only one link on a page that says destinations, then this works, right? So it tries to find like the simplest way it can locate something. These are called locators. So it tries to find the simplest locator you can use. And this is how it tries to make tests be less flaky. Because if imagine your CSS changes behind the scenes, like you do a whole new thing, as long as you still have a link called destinations, then your test is still going to work. All right, so then we can go on here, and then we might click on this one, and you can you just keep clicking. Like let's try like filling out a form. So here, and so we'll get the code for filling out the form. And once again, you can see, in this case, it's getting by label, because a label is considered a user-facing thing, right? So we, click that, we fill it out. So generally, you should just always try to use the Playwright Code Gen tool versus going to the documentation and figuring it out that way, because the Playwright Code Gen tool is designed to come up with the least flaky locators for you. So then you can like take all this code, you can go and copy and paste it into your tests, and then write whatever asserts you want to assert, right? Like if you wanted to assert some text was there, then you could write that assert. So that's my general approach to writing these Playwright tests for web apps. So then you can go ahead and see the tests that we've actually written. Like let's look at, most things are just kind of clicking on links. And then after we click on the link, we could check the URL. So in this case, we like check the URL, we check the title, we check the text of, some locator here. So in this case, we did decide to use a CSS thing. So you can also use CSS, but that might be a little flakier. All right. So we've written the test, and now finally we need to run them. Let's go ahead and run these tests. So we can run the tests inside the code base and inside the code space. So we'll say python-m Pytest, and it'll just run all the tests it can find. And in this code base, we only do, we have Playwright tests and we have one other kind of test, but we don't have any integration or unit tests in this code base because we decided to go Playwright first. So you can see this is running, and there's quite a few tests in here. There's more than you think there are, because I've used something called parameterization in order to get it to run a particular test multiple times, but for different parameters. So in this case, it's like checking 3 different pages. For this case, we've got destinations and cruises, and we parameterize using the destination. So it's going to run that test for every single destination. And you can see as it's running, you can see the parameters that got passed in. So it's like, okay, it's running with Chromium, and it's running for each of these destinations. So even though it only looks like maybe like 6 test functions or something, it actually ends up having quite a few tests because of the parameterization. So that's another nice thing you can do with Pytest is parameterize. So instead of having to write the same very similar test 20 times, if it only differs by a single parameter, then use the parameterize in order to run it all those times. Okay, so all those tests pass. Now, what happens if it fails? Well, what you can do is you can do tracing. And well, actually, first I'll just show you running in headed mode, because I don't know, it's kind of fun. So let's see. We're in it right now. Okay, so let's say we did, is it gonna let me run it from here? Headed mode. Actually, I don't think, I had headed mode set up over here. Okay. All right, let's do python-m pytest test/ede. And then I'm going to say headed mode. So I'm telling it to run in headed. Normally it runs in headless. So headed means we should actually see the Chromium pop up. So let's see what happens. Hands off the keyboard, not touching the keyboard, just gonna watch the magic browser do its thing. Okay, it's starting up. And there we go. So you can see it's loading up a browser and it's going really fast. This is testing an AI chat application. You might be able to briefly see it. You can slow it down using this slow-mo parameter. It's funny to see how fast it goes. Yeah, look, see, no hands, no hands. It's not me. I always loved, even when I would use Selenium, I just thought this was so fun to just, have this robotic browser doing my bidding. But Pytest has all of these great options. So you can slow it down. You can have it take screenshots. You can have it take videos. I actually use Pytest sometimes just for taking screenshots, not even for testing, just if I'm trying to like document something or something. So it's running through a bunch of tests there, and you can see it's like clicking lots of buttons and checking various things. So you can watch your tests if you're really into that and you've got like a good lunch to eat while you're watching them. I'm gonna close that down. So stops that. All right, now I'm gonna run it with tracing on. So this is something you can do where even if you can't watch the test or watching the test isn't that useful, it's too hard to slow it down, you can do tracing equals on or tracing equals retain on failure, either of those. I'll just do on since none of mine are failing right now. So what it's going to do this time is that for every test it runs, it is going to create a trace of it. And you can see it just added this test results folder. And you can see that it's actually adding traces as it goes along. And each of these traces is actually a zip. And that zip contains this trace that we can then view using a local trace viewer or this online trace viewer. So let's go ahead and let me see. I wanted to do a more complicated test, maybe this one. Let's see. So I'll just download it from the code space. And then you just go to trace.playwright.dev. And then we can just drop a trace in here. And you can also, there's a local command you can do as well. So what this does is it shows you this timeline of exactly what it did. And this is so cool because you can also like do this with your CI. So we can see it went to the page and this is what the page looked like when it did it. And it clicked on destinations and then it checked the title and then it was done. Okay, so this one was not a super exciting test. It'll show you each of the steps of your test. I think they get a little more interesting as they go on. But this is super helpful because if any of your tests fail, you can just open up this trace and see, oh, okay, that's why it failed. Is because this particular thing didn't exist at that point. Let's see. Okay, there is a couple questions. Is the get by role link way of finding a web locator not possible to use in Selenium? Yeah, that's a good question. So I'll admit, like, it's been a while since I've used Selenium. I think you could probably do something similar to try and make Selenium tests less flaky as well, is to try and say like, well, if our CSS is changing all the time, let's, look for something based off of their, the link title. I think you could totally code that in Selenium. I think the thing with Playwright is that like they're kind of trying to optimize for that and really recommend that as the way to do it and build tools around it, like that code gen tool, because the code gen tool is like actually like doing some sort of clever calculation where it's looking to see like, okay, what are all the possible labels on this page? What are all the possible titles? What's the most, simplest, unique locator I can use? So I do think there's ways to making Selenium tests less flaky for sure. And if you're doing Selenium, that's a good thing to look into. But this is the way of doing it in Playwright. And you'll see also my Selenianisms in the test, right? The fact that you see that I do have CSS locators is because I come from Selenium where, we tend to do everything by CSS locators. So that is totally my Selenium experience leaking into Playwright. What I should have done is actually, used the code gen or just, used a more user-facing locator instead of that CSS selector. Great question. Another question is, would it make more sense to have Playwright testing against a local Docker container that runs the web app? Yeah. So yeah, if you are working with Docker containers, then you could have your, I guess you could have your conf test. You just have to be able to pass in the URL into your test. So if you have some way of passing in the URL, and we have set ours up to be able to pass in a URL, because we also run these tests on CI/CD. So we and CI/CD, we can run them two different ways. We can run them on like our local mocked out, server, or we can run them as smoke tests. And the smoke tests are actually going to take in a URL. So that's another way you could do it. So you could take a look at how we've done this here. If you want to be able to like kind of just specify the URL, and you've got that URL like running for a container or something like that, then that would be another way of doing it. And that's what we do for our smoke test. So if you look at here, our as your dev workflow, this is the workflow that deploys. After we do the deploy, first we just do a curl and sleep until we get the curl to work, and then we install Playwright and we tell it the URL of the live server, so that way we can actually run these tests against that live server URL. So that's how we're doing our smoke tests, and we're also running these tests against like a local Postgres local server, inside our normal CI. So this is a cool thing is with these Playwright tests is that, and I think this is the best way to use them, is to both use them for, your CI tests to make sure that changes are working, with your kind of locally set up app, and then also use them, or at least a subset of them, right? Maybe not all of them. Maybe you just set up a subset, or maybe you have a different set of tests, run a subset of them as smoke tests against your deployed application to make sure that all your top user flows are working. And so that I think can work really well. Okay, right. And then what else? You also see in this app here is that I'm actually running accessibility tests as well. Hello, dear toddler. Okay. And I guess Sierra's going to say hi for our last session here. Sierra, we have 3 minutes left. Did you have anything to say? Mommy. There she is. Okay. All right. She always likes to crash at the very end of these seasons. But okay, so in our last 3 minutes, here we go. The interns get younger every year. Yeah, so if you want real testing, just have a toddler bang on your app. My gosh, like she can just break everything. It's really, really impressive. Okay, so let's see. We are also doing accessibility testing in this one. So if you're interested in checking your websites for accessibility issues, that's something that you can do as well. And I've got several blog posts about that you can read for more, because there are kind of two different ways that I do it. But we basically just can check for accessibility violations. And I think that's a really nice thing to do as well, because as long as you've got the website up, you might as well check to see if there's any accessibility violations that you can fix and make your web pages more accessible. So read my blog post about that if you're interested in that. Go through and try and add a test yourself if you have time later and want to try that out. And then in our last minute, testing workflow. When should you write tests? Or when should you run tests? You can run them using pre-commit if you want to do that. I usually don't, just because they're kind of often a bit slow to run. What I usually recommend is like obviously run your tests when you're developing changes, but then make sure you're also running tests in CI. And we actually were just looking at the CI workflow, so we've already talked about this. But here's the most basic workflow for running Pytest. Remember that you can do fancier things, like you can upload traces. If you're trying to like upload traces from Playwright, you could do that in your in your tests. Let's see, where did I do it here? Oh, maybe I don't have it in this one, but I have another one where I actually upload traces. I think it's in this one. There's always got to be in one of our in one of these things. So this one, Python test. Okay. So remember, you can do stuff like fail under in your CI to make sure people aren't trying to sneak in code without coverage. And then here, when you're doing Playwright, you can do retain on failure, and then you can upload the Playwright traces using this upload artifact. And so that way, if you do get a Playwright failure, you can get the artifact, you can download it, and then you can check it out in the trace viewer, either online or locally. So there's a lot of really cool things you can do when you're running tests in CI. I've got other repos that you like add a comment with the coverage and stuff like that. So you can really, really, do a lot with your CI and try and enforce that people are writing tests. And that is what I have for you today. Thank you all for the great questions and for being engaged this whole series. If you want to see more series about Python and other stuff, we've got our next one coming up in July is going to be about securing AI apps on Azure. And it is actually all going to be Python examples because we're the Python team. We're putting it on. So do come back for that one. I will be figuring out how to make my hair silver for that one because you all voted for it last time. So that's going to happen somehow. So I look forward to seeing you all in the future. Bye.
Thanks, everybody, for joining us. Thanks to Pamela for another awesome session. You can learn more about this series and view past episodes at the URL at the bottom of the screen. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 22147. We'll see you for the next series.